So in grade 11, you learned that a negative outside of a parabola made the parabola go down. In grade 12, sometimes the negative is going to be outside the function, like it was with your parabolas, and sometimes it's going to be inside the function. So we've got a function here, f of x. It is a parabola. And if you put a negative out in front of that equation, what it would do is it would take that equation and flip it over the x-axis. And it would take the y value and make it negative. So what I've done on this graph is I labeled the point 8, 4. And if 8, 4 is on f of x, then if you put a negative out in front, outside of f of x, you would have the point 8, 4. All that's happening with a negative outside the function is your y value is becoming negative. Graphically, what that does is if you took all of your y values and made them negative, it would flip it or reflect it over the x-axis. And so what I'd like you to do is off to the side, where you have some space, write the following note. So you have y equals negative f of x. Sometimes that's written with a negative on the other side. And we'll say if the negative is outside the function, and sometimes this is called with the y because you could put the negative with the y, then this is a vertical reflection. So that vertical reflection part is going to be important for explain or describe questions. And that is a reflection. A vertical reflection goes over the x-axis. Algebraically, the y values are all getting multiplied by a negative 1, which we saw with our point 8, 4 gets switched to 8, negative 4. Now with parabolas that you worked with last year, you never had to worry about negatives inside the function, because a parabola, if you reflect it horizontally, is the same parabola that you started with. If you had a basic x squared and you flipped it over the y-axis, you'd still have the basic x squared. So in grade 11, they didn't have to worry about horizontal. A word you want to learn about?
The one after vertical.
Vertical reflection. Yeah, it's beautifully written there. Yeah. Then this is a vertical reflection over the x-axis, and the y values get multiplied by negative 1. Next, we're going to look at what does happen if you put the negative inside. Well, if that was my function f of x, and I put a negative inside, that's going to reflect it over the y-axis. And I'm going to label that point. If I had 8, 4, I would now have negative 8, 4. So all that's happening is your x value is getting multiplied by negative 1. So we'll write a note for that one as well. If that negative is inside the function, in other words, the negative is with the x, or where the x was, then this is a horizontal reflection. And we say a horizontal reflection is over the y-axis. Algebraically, your x values are getting multiplied by negative 1. you know which one? Do they have their? So with that in mind, we can go to example 1. And again, this time we're just given a random graph in function notation. It says, sketch the image graph after reflection in the y-axis. So the first thing I want us to do is, I want us to underline reflection in the y-axis. And one of the things that math classes like to do is ask the same question with different words. So this, sketch a graph, the reflection in the y-axis, can come up in 3 different forms. They could say reflection in the y-axis. They could say after, and then give it to you. Now, reflection in the y-axis, can you see that that is a horizontal reflection? So horizontal reflection would be a negative inside the function. So instead of saying sketch the graph after reflection over the y-axis, they could say sketch the graph of y equals g of negative x. And you'd have to know that that's the same thing. And sometimes they have the actual equation of the y-axis. The equation of the y-axis is x equals 0. And I guess technically a fourth way is they could have just said a horizontal reflection. So one of the things that you want, and the reason I showed you all 4 of these, is when you see something like a reflection in the y-axis, I want your brain to run through exactly what that means. Okay? So I imagine something flipping over the y-axis. It's pretty easy to see that that's horizontal because things are moving left and right. Once I know it's horizontal, I should think of the function notation of g of negative x. Right? And it's not bad to think of the y-axis also as a line x equals 0. The more of these connections we make, the easier other questions become for us. So all that's going to happen, okay, is you're going to multiply your x values by a negative 1. Like if I take this point here, which is at 5, 2, and I reflect it over the y-axis, I'm going to get the point negative 5, 2. And all that's happened to that point is it's been reflected. Maybe your brain is good at taking this image and in your head flipping it and sticking it back down. Okay? But algebraically, like there I have the point 3, negative 2. When I flip that, that's going to be negative 3, negative 2. And we can do that with each of these points. This one's at negative 1, negative 2. It's going to become 1, negative 2. And this one at negative 3, 1 is going to be 3, positive 1. Yes. And now we can just join those points, connect them together, and we have our reflection. And again, I'm going to label it in terms of the function g, just so we get a practice with that notation as well. Now the question does ask for the domain and range. And one of the things you're going to notice when I do domain and range, I'm going to switch between interval notation and set notation so you get used to them both. You can choose when you do a question whichever way you like to rank. Okay? But for this one, if I did interval notation, okay, domain is x values. What is the smallest x value on my red graph? Is minus 3. And the largest value on of my x's on my red graph is 5. So it goes from -3 to 5. For my range, the smallest y value is -2, and my largest y value is 2. And in the interval notation, this means that every x in between -3 and 5 is hit, which is true because the line connects between the two. And every y between -2 and +2 is hit, and that's true because there's a line going through everything. Okay. On the blue graph, now my domain, my smallest x value is -5, and my biggest x value is 3. And for my range, my smallest is still -2, and biggest is +2. Does it make sense that the range didn't change? Because algebraically, all we did was multiply the x by something. We didn't do anything to the y's. And since we didn't do anything to the y's, our range didn't change. But because we multiplied our x by a -1, do you see that the domain got multiplied by a -1? The 5 became the -5, and the -3 became the +3. And so your domain changed as a result. All right, circle questions 3 and 13. And sometimes I'm going to tell you things that I do in my head that I don't say out loud. Okay? I don't know if you noticed, but before I wrote down 3 and 13, I reread the question in my head. You probably didn't notice that, right? Because it would be like it's invisible, okay? But I'm telling you out loud because these are things you have to do for math questions. You should never finish a math question and not read the question again. Because I guarantee if you do that, you will miss stuff, okay? I guarantee sometimes I'll forget and I'll do a shortcut and you'll be like, didn't we miss something in that question? I'm like, oh, you caught me. You caught me doing exactly what we all want to do. We want to just move on to the next question because we think we got it, but we should read it again and see if there's anything that we missed.